Now we will see the another example for the limit. See, for example, we have the function f of x is equal to x square plus 5x plus 8, and now we want to find out the limit for this function as x tends to 1. So we consider limit x tends to 1 f of x. So this is equal to limit x tends to 1 x square plus 5x plus 8. Now this x tends to 1 means x is going to be very close to 1, nearly equal to 1, and that's why we replace the value of x by 1. So we get 1 square plus 5 into 1 plus 8, and hence it will be 1 plus 5 plus 8. So we get here this is going to be 6 plus 8 is going to be 14, and hence we can write limit x tends to 1 f of x is equal to 14. This way we are able to apply the concept of limit x tends to 1 f of x, and we get the value to be 14. Now we consider one more example. See, let's consider f of x is equal to, we have x cube minus 3 cube upon x minus 3. So we want to find out the limit for this function x tends to 3. Then we consider limit x tends to 3 f of x. So this is equal to limit x tends to 3 x cube minus 3 cube upon x minus 3. Now if we see, if I put x is equal to 3, then the denominator is going to be 0. If I put x is equal to 3 in the numerator, numerator is going to be 0. But we can factorize this numerator, and we can have limit x tends to 3. So this is x minus 3 into x square plus 3x plus 3 square, and hence here I have x minus 3. Now we have a common factor in numerator and denominator, so we can cancel this, and then we have limit x tends to 3 x square plus 3x plus 3 square. And now this is as per the previous example, we are able to put the value of x is equal to 3. And now if I put the value of x is equal to 3, what I'll get is, I'll get 3 square plus 3 into 3, and you will be having 3 square. So this is going to be 9 plus 9 plus 9, and so this is 27. Now what we got is, we got the limit x tends to 3 f of x is equal to 27. So this way we are able to apply the limit for this function, and we can calculate the limit of this function as x tends to 3. Now we will consider one more example for limit. See, what we can have is, suppose we have the function f of x is equal to x minus 2 upon x square plus x minus 6, and now we consider the limit for f of x as x tends to 2. Now this is what we will be having, limit x tends to 2 x minus 2 upon x square plus x minus 6. Now see, if I put the value of x is equal to 2, then I am getting numerator is equal to 0 again. If I put the value of x is equal to 2, then I am getting denominator is equal to 0 again, because I will be having, this is x square, 2 square will be 4 plus 2 6, minus 6 is going to be 0. And now that's why we need to search for a factor if there is any. So we can factorize this denominator as limit x tends to 2 x minus 2 into, this will be x minus 2 into x plus 3. So we have the product minus 6, and the sum is going to be plus 1, and hence we have this factorization. Now see, the numerator and denominator, we have a common factor, so we can cancel it out, and then we get limit x tends to 2, you will be having 1 upon x plus 3. And now here no term is going to be 0, that's why we can put the limit, and hence if I put x is equal to 2, we get 1 upon 2 plus 3, that is 1 upon 5, and hence we got the value of the limit x tends to 2 f of x is equal to 1 upon 5. So this way we are able to calculate the limit